Moles. First of all, let's define what a mole is. 1 mole of any substance. Does anyone know? How would you define a mole in a question if it asked you what is a mole? Avogadro's constant. Yep, you mentioned Avogadro's constant. It's linked to it. The number of atoms. Good. So I think when I join people's answers together, it's right. So 1 mole of any substance contains the same number of particles as Avogadro's constant, and that is 6.02 times 10 to the 23. So that's how many particles you have in 1 mole of any substance, no matter what it is. If it's carbon, if it's water, if it's oxygen, if you have 1 mole of it, a mole is just a way to measure it. So it's an amount of substance. If you have a mole of any substance, it always has this many particles. So this equation comes into that because moles is equal to mass over mR, and 1 mole of any substance always weighs the same mass as the relative atomic mass, or the atomic mass of the substance itself. So, for example, let me explain what that means. If you had 1 mole of carbon, its mass would be 12 grams, because if you look in the periodic table, in carbon, you'll find the numbers 12 and 6, I think. By the way, for today's session, guys, I would recommend just having a periodic table next to you. It might help with the calculations. It will help with the calculations. So yeah, 1 mole of carbon has a mass of 12 grams, yeah, because there's a 12 there. So basically, the bottom number is the atomic number, the top number is the mass number. The 12, the bigger number, always is the mass of 1 mole of that substance. So if you had oxygen, for example, oxygen is 16 and 8. So 1 mole of oxygen would weigh how much, guys? Yeah, 16 grams, exactly, 16 grams. So 1 mole of any substance contains the same number of particles as Avogadro's constant, but also we can say, this is the definition, you can also say 1 mole of any substance has the same mass as the MR of that substance. When I say MR, I mean the molar mass or the relative atomic mass. So you can say AR as well. MR, how do you find out the MR of a substance? So like if we had H2O, for example, if we wanted to work out the MR of H2O, how would you work that out? So you add up the atomic mass of each element. Good. So you go to exactly 18. Thanks. So you go to the periodic table, you look at hydrogen, it's a 1 and a 1. Oxygen we've got up here is a 16 and an 8. And what you do is you get the big numbers and you add them together. So H2 means there's 2 hydrogens. So it's going to be 1 plus 1 because the hydrogens have a 1 on them. And 1 oxygen, so 1 plus 1 plus 16 is equal to 18. And that gives us the MR of H2O. Okay, so that comes back to this part, which is moles equals mass over MR. So if you ever want to work out how many moles you have, you take the mass of the substance, divide it by the MR. So the MR, you use the periodic table to work that out. Mass is given to you. So mass would be, what would mass be measured in usually? What were the units? Grams, exactly. So it won't always be grams. You'll see some examples where it's not grams, it might be kilograms. But to use this equation, usually you have to have it in grams. And moles is measured in, the units for moles is literally just moles, MOL. That's the units for that. Okay, so that is just a quick summary. We'll add to this if anything else comes up. So let's get into the questions, sorry. Right, let's look at this. So ammonia is produced from nitrogen and hydrogen. The equation for this is N2H2NH3. Company wants to make this much ammonia. Calculate the mass of nitrogen needed. Okay, so I am going to add to this actually. So this is a mole calculation. So this is what we're going to do. We're going to see quite a few questions like this. And there might be, everyone does it a different way. But for today's session, I'm going to do these steps. So mole calculation steps. So you might do it differently, that's fine. But just for people who don't know how to do it, first step I tell people to do is on the equation, basically note down the known and unknown substances. And I'll explain what this means when I get into a question. So the known and unknown. So the known means whatever substance you know the mass of. So I would say 16 grams of something. That's the known substance, okay? So what you know. And the unknown is what you're trying to find out, what the question is asking you to work out. What you want to find out. So that's our first step. Yep, I'll give you a chance to screenshot it, guys, in a second. Second step is to work out the moles of the known. I'm hoping it becomes clear when I do the questions, guys, so don't worry if you're getting confused right now. Work out the moles of the known. Remember, the known is what you know. Third step is to use the ratios. Do you guys know where we get the ratios from when you do these calculations? Thank you for the rose, Jordan. Thank you. So use the ratios to find the unknown moles. Yeah, it's in the equation. So the balanced equation. Thank you. So to find the ratios, again, guys, when I do the question, it'll become clear. You use the balanced equation to find the unknown moles. Okay. And then your final step is to find the unknown mass. Okay. Going back to the second step, when I say work out the moles of the known, I mean use this equation. So use, let me use a different color so it doesn't get confusing. So use moles is equal to mass over mR. All right, these are the steps that we're going to use for that first question. Why don't you guys take a screenshot so you can maybe look back at it or something. I'm going to add to this as we go as well. All right, so step 1, 2, 3, and 4. Okay, so 4 steps. Ammonia is produced. Here's our equation. Company wants to make 6.8 tons of ammonia. So our first step, remember, is note down the known and the unknown. So what do we know the value of and what do we want to find out? So in this question, guys, what do we know the value of and what do we want to find out? What do you guys think? What substance, known is ammonia, good. Unknown is hydrogen. Known is ammonia because it says 6.8 tons of ammonia. So we know ammonia. Ammonia is NH3. So we can put, let's put a K here for the known. And we know it's 6.8 tons. So let's put 6.8. So do this on your exam papers if you want. So that's what we're starting off with. Our unknown is not hydrogen because the question's asking for what? It's nitrogen. Yeah. Thank you. So we need to find the mass of the nitrogen. So we're going to put a U on the nitrogen. Okay. So your next step. So we've noted down the known and the unknown. Our next step, according to our calculation step, work out the moles of the known. So this is when you use moles equals mass over mR. So this is when you start writing this on your sheet. So moles equals mass over mR. What mass are we going to use here? What do you guys think? What are we going to put as the mass? 6.8. It's 6.8 tons. So 6.8 tons, remember we need it in grams. You can get away with putting it in, leaving it as 6.8 as well, but you can also convert it into grams. If you convert that into grams, you basically have to times it by 1,000 twice. But let's leave it at 6.8. So mass is 6.8. MR, what's the MR of ammonia? Yeah, thank you. So you can convert it to grams. So in kilograms, it'll be 6,800, and in grams, it would be another 1,000 greater. But you can leave it at 6.8 in your calculation. So MR of ammonia is 17, not 14, because look, it's NH3. So you have to do 14 plus 3 ones. So it'll be 14 plus 1 plus 1 plus 1. So basically 6.8 divided by 17. What does that give us, guys? Anyone got a calculator that can work this out? This question's higher. So 6.8 divided by 17. 0.4, thank you guys. 0.4. That is our second step done. Okay, so third step, use ratios to find the unknown moles. Okay, so ratios, guys, is when you look at the numbers in front of each substance. So you see here, our known has a 2 in front of it. When you balance it, you have a 2, right? And our unknown has no number in front of it. If it has no number in front of it, that's basically a 1. This has a 3 in front of it, but we're not worried about the 3 because the 3 is not involved in this calculation. So the ratio, what's the ratio that we have here? So the ratio has to be from the known to the unknown. So what would you say the ratio from the known to the unknown is? Okay, some of you put 1 to 2, some of you put 2 to 1. Which one is it? It's the known to the unknown. So people would get basically confused. 2 to 1, yes, exactly. 2 to 1 because it's known to unknown, so it's going to be 2 to 1. So the ratio is 2 to 1. Good. So that means for every 2 moles of known, you have 1 mole of unknown. So we've just worked out 0.4 moles of the known. That's of ammonia, isn't it? So of NH3. So if we got 0.4 moles of ammonia, how many moles of nitrogen would you have? What would you need to do? Yeah, basically you need to divide this by 2. So what you would do, because it's a 2 to 1 ratio, you need to do 0.4 divided by 2, which gives you 0.2. So that's 0.2 moles of N2. That's our third step done. Now our fourth step. So we've got our 0.2 and our fourth step is to find the unknown mass. And that's by using basically this equation again. But we want to rearrange this equation. So we're rearranging moles is equal to mass over mR. You want to rearrange it to make mass the subject because that's what we're trying to work out, isn't it? We're trying to work out the mass. What do you get? What do you have to do for your calculation to work out mass? So mass is equal to moles times mR. Thank you very much. So mass equals moles times mR. So we get this 0.2 moles times it by the mR of our unknown, what we're trying to find out, our N2. What's the mR of our N2? Thank you. It's 28. It's 28 because it's nitrogen. If you look at nitrogen in the periodic table, actually it tells us here what nitrogen is. Nitrogen is 14, but there's 2 nitrogens because it's N2. So that makes it 28. So we do 0.8 times 28, which gives us an answer of 5.6. Thank you, guys. Right, who's got any questions on this one? Let me answer any questions. Is there any steps you guys didn't understand? So we got red step, purple step, blue step. Sorry, green step. Where did I get 28 from? 28. So this is the unknown. Remember, the step is find the unknown mass. So that means when we do moles times mR, we have to do the mR of the unknown. We've marked our unknown as N2. N in the question says it's 14. So N2 would be 14 plus 14, which is 28. Does that make sense? All right, good question. Someone asked, because there's a 2 in front of the nitrogen here would you not do times 2? Because it says 2NH3, if you want to work out the MR of NH3, you don't add the big numbers. You don't include the big numbers. You only look at the small numbers. So you only look at this 3. This 2, if you remember, we use that for the next step, for the ratio step. So we do take it into account, but only in step 3, in this third step. So in step 2, you don't need to times it by 2, only in step 3. Otherwise, you'll be timesing it by 2 twice unnecessarily. Okay, good. People are understanding. Okay, so I'm going to leave this question for now because that's a triple question. I'll come back to that in a second. Let's go on to this question here. Carbon dioxide can be formed by the reaction of calcium carbonate with dilute hydrochloric acid. Write the balanced equation. Right, what is the reactants for this? What are the reactants? This would be paper 1, guys. Good. Thank you. So reactants, it's saying reaction of calcium carbonate with dilute hydrochloric acid. So our reactants are going to be calcium carbonate, which they've told us what it is up here, CaCO3, with hydrochloric acid, which is HCl. So this is a carbonate being reacted with an acid. This is actually not a moles question, but in a you probably won't get one full moles question. It will just be a part of a question. So what is this going to form? Any idea? What happens when you get an acid and you react it with a carbonate? Does anyone know? CO2 gets formed. Yes, we are going to get CO2 formed. CO2 is one of the products. Salt, carbon dioxide, and water. Yep, thank you very much. So salt, carbon dioxide, water. We'll write the water down. Salt, we need to figure out what the salt is. What's the salt? We've got calcium, we've got chlorine here. Right, good. Calcium chloride. Someone put CaCl2, someone put CaCl. Which one is it? Is it CaCl or is it CaCl2? And how do you work it out? Okay, we're getting a mix of answers here. The way to work it out, guys, is to work out the charges of Ca and for Cl. Ca is, if you look at the periodic table, Ca is in group 2. So what charge is Ca going to have? If it's in group 2, what charge would it have? Not 2 minus, it'll be 2 plus. Metals only have positive ions. Chlorine, what charge would chlorine have? That's group 7. Chlorine's group 7. Minus. Good. Thank you, guys. So what you do here is you basically, there's a method where you swap the numbers around. So minus basically means -1. You swap the numbers around. This is another topic, guys. It's not part of moles, but I'm just teaching this anyway. So you get Ca1, you get 1 on the Ca, but you never write down ones, and then Cl2, because the 2 from the Ca comes here. Basically, for every 1 Ca2 plus ion, you need 2 Cl minus ions. So CaCl2. I don't want to spend too long on this because I want to focus on mole calculations today, guys. But yeah, hopefully that makes sense. We just need to balance this equation now. To balance it, I'll tell you guys, it'll be a 2 here. Yeah. So yeah, like I said, I don't want to spend too long on this question. I'd rather do the next one, which is another mole calculation. So let's move on. This is the important one. We've got this reaction going on. 15 grams of pure copper carbonate is decomposed completely. Calculate the mass of solid produced. Right, first of all, tell me guys, what's the known and what's the unknown? What do we know the value of? What are we going to put K on top of? And what are we going to put a U on top of? Known is CO2. Not quite. Copper carbonate is known. Yes, copper carbonate is known. It says 15 grams of pure copper carbonate. We know the mass of copper carbonate. So we're going to put K there for unknown. What are we trying to find out? So let me just write 15 grams there. It hasn't told you directly, by the way. It's only told you calculate the mass of the solid produced. So you need to look at this equation and see which product is the solid. Thank you guys. It's copper oxide because it's got an S on it. It's a solid. So that's our unknown. That's what we're trying to find out. This is what they're going to do in the exams, guys. They might not make it obvious. You need to think a bit. They're going to try and trick you. So we've got our known and our unknown. Let's go back to our steps because someone asked to see them again. Steps. We've done our first step. Note down the known and the unknown. Next, we're going to use moles equals mass over MR. Then we're going to use the ratio. Then we're going to find out the unknown mass using the same equation again. So we're on this one. 15 grams of pure copper carbonate. Okay, so our known, we want to work out the moles of our known. So moles equals mass over MR. So what's the mass that we're going to use? Not mass times MR, it's mass divided by MR. 15 grams, thank you. 15 grams divided by the MR of copper carbonate. So you guys need to calculate CuCO3. We've got the numbers here, Cu, O, and C. Can you guys try and calculate that? Tell me what you get. CuCO3. So 1 Cu, 1 C, and 3 oxygens. Tell me what you get. We're getting loads of different answers. It's not 91.5. How did you get that? Let me see where you guys are going wrong. 16 plus 12. Okay, you're getting 91.5 because you're forgetting there's 3 oxygens. You need to do 16 3 times. Thank you, Chrome. I think you've got it. Okay, so this is what you have to do, guys. Cu is 63.5. Plus C12 plus O3, CuCO3, you need to do 3 oxygens. So 16 plus 16 plus 16, which is 123.5. So 15 divided by 123.5, what does that give, guys? .121. Thank you very much. This is what you get, 0.121. Okay, that's our second step done. Third step is the ratio. What ratio do we have here, guys? Known to unknown. Remember, we want the ratio of the known to the unknown. We just want the numbers in front. 1 to 1, exactly. No number here. No number here. There's no balancing numbers in any of these. It's not like there's a 2 here. It's just 1 to 1 to 1. So it actually makes it really easy. It's a 1-to-1 ratio. So that means if we have 0.121 moles of copper carbonate, 0.121, that means you're going to have 0.121 moles of the unknown, which is CuO. So that is our third step done. On to the final step. Our final step, reminder, is find the unknown mass. We're using the equation again, but we're rearranging the equation. So mass is equal to moles times MR. So it's going to be our moles, 0.121 times the MR of what? What MR are we using this time? It's not the same. It's not the same MR as before because that was for CuCO3. For CuO, exactly. Because that is our unknown. You want to work out the MR of our unknown. So CuO, can you guys try and work that out then? MR of CuO, tell me what you get. Yeah, thank you, Austin. Thank you, Oscar. 79.5. So that's not the final answer. 79.5 is the MR. So now we just need to do 0.121 times 79.5. What does that give us? So 79.5 times 0.121, we've got an answer of roughly 9.6, I think 9.9 is a bit too high. 9.93, right, let me try this myself. Let's see what I get. So around 9.6, 9.7. It's not going to be exact. It's saying to two significant figures. It's not going to be exact because it depends where you round it. When you do 15 divided by 123.5, you don't get exactly 0.121. You get 0.12145748999. So what I tell people is keep this number in your calculator and carry on using it in the next step. So don't round it too early. If you round it too early, your final answer, you're going to lose a bit of accuracy in your final answer. So you do this, then you times this number by 79.5. Times it by 79.5. And you can see here, it's gone from 9.6 to 9.7. So if you write 9.6, you would have lost a mark. The answer is 9.7 grams. It says to two significant figures. So let me repeat what I said, guys. Don't round your answers too early. Use the actual numbers that you have in your calculator. In the first step, when you do your first step, keep this number in your calculator and do, in the next step, do answer times 79.5 rather than doing 0.121 times 79.5, do answer times, because if you do this, you're going to lose a bit of accuracy. That's why you got 9.6 grams. But if you do it with the actual answer, you get 9.7 grams. How many marks is this? This is 2-mark question. I think normally it would be 3 marks, more calculations. This one was only 2 marks. How do you know which one out of the two products is the unknown? Because it doesn't say in the question. Yet unknown is always the one you're trying to find out. It says calculate the mass of the solid. So you have to basically work out which one the solid is out of the products. And because that's got an S on it, it's the CuO. Does that make sense? Let's move on. Right, we have another reaction. Magnesium plus 2H2O forms magnesium hydroxide plus H2. 2.5 grams of magnesium reacts with sufficient steam for a complete reaction to form 5.8 magnesium hydroxide and 0.2 grams of hydrogen. A lot of writing, it'll throw people off. Show by calculation that the law of conservation of mass applies. What is the law of conservation of mass? Can anyone tell me? What does the conservation of mass tell us? Mass of the reactants is equal to the mass of the products. Yep, thank you, Oscar. Let's add this to our notes. Conservation of mass. Mass of reactants is equal to mass of products. This is what we need to prove. So yeah, that means the mass needs to stay the same on both sides. So mass of Mg and 2H2O needs to be equal to MgOH2 plus H2. What information have we got? So we have to read the question. It says 2.4 grams of magnesium. So 2.4 grams of magnesium reacts with sufficient steam. They haven't told us how much steam there is. The steam is the H2O because that's just water as a gas. For a complete reaction to form 5.8 grams of magnesium hydroxide. 5.8 grams and 0.2 grams of hydrogen. Show by calculation the law of conservation of mass applies. So basically what they want you to do is to work out this value here. And when you work that out, you do 2.4 plus that number and it should equal 5.8 plus that number. How can we go about working this out, guys? We need to work out the mass of that, basically, of the water. So you can't just do 6 minus 2.4 because we know it's 6 because these two are added together to make 6. We need to work this out another way and prove that adding them is equal to 6. So doing 6 minus 2.4 is just going to tell us what we need to end up with at the end. It doesn't tell us, it doesn't prove anything. It just tells us that's what we should get. Yes, okay, I'm hearing the right answers. So you have to do mole calculations, exactly. So this time, we want to work out H2O. This is our unknown. This is what we want to work out. Our known, you can use any of these. Because we have the mass of all of these, we can use any of these. But let's use magnesium. That's the easiest one to work out. That's our known. Okay, so let's follow our steps. Our first step is to do moles is equal to mass over mR. So our mass is 2.4 grams divided by the mR of Mg. We have that here. It's 24. So you do 2.4 divided by 24. That gives us 0.1 moles of Mg. Okay, now we need to do our second step, which is the ratio. What's the ratio we have here? The known to the unknown. What's the ratio we have? 2:1, not 2:1, 1:2. 1:2, yeah. So in your exam, make sure you write down 1:2, not 2:1. 1 to 2, so that means we need to times this by 2. Yes, I'm hearing the right answers. So we do 0.1. Sorry, this is 0.1, isn't it? 0.1 for the known, and this is 0.1 times 2, which is 0.2 moles of water. Okay, and our final step is to do our mass calculation. Mass is equal to moles times mR. So that's going to be 0.2 times by, what's the mR that we're going to use this time? Where did I get 0.1 from? From here. We did mass over mR. That's where I got it from. So I did the mass of 2.4 divided by the mR of mg, which is 24. H2O, it's not 36, it's H plus O, so it's 18. Yep, exactly, 18. Not 36, it's 18. You don't include the 2's when you calculate the MR. You don't include the big numbers because you're taking account of it in this step here. So 0.2 times 18, which gives 3.6. Therefore, this all works because that means this is 3.6. And when you do, so you have to write this in your exam paper, 2.4 plus 3.6 is equal to 6 grams. And then on this side, we have 5.8 plus 0.2 is equal to 6 grams. Therefore, mass is conserved. Do I have the sheet of the equations we need to know for this? There is no sheet for chemistry, unfortunately. You just get given the periodic table, so you need to memorize it. Thank you, Georgia. That's good to hear. How do I know when to work out moles? How do you know? Because it's usually in a question where they give you the mass of one thing and they want you to work out the mass of something else. That's when you start using moles. Any other questions on this one, guys? So if you do a mole ratio, you don't have to multiply it by 2. If you do a mole, if you do this ratio step, when you do a ratio step here, if you've taken into account these big numbers, when you work out the MR on the next step, you don't need to take that into account. You ignore that 2 because otherwise you're just timesing it by 2 twice unnecessarily. You just need to times it by 2 once. Topic name, quantitative chemistry or moles? Yeah, exactly, Oscar. So only MR of H2O. Okay. Good to hear. I'm helping, guys. Could have used hydrogen on the other side as your known. Yes, you can, Lena. Yeah, you can. You could have used any of these as your known because we know the mass of them. So you could have done this. It would have been more difficult because you would have had to work out the MR of all of this. You could have used hydrogen. That would have probably made it easy as well. But we just picked magnesium. Will this be on your YouTube? Yes, I will put this on my YouTube. Guys, let me tell you guys now. So I'm putting my lives up on my YouTube. It's Flash Version Lab. I just put the electricity live that I did on Sunday, and I'll be putting yesterday's biology live as well. So join this, guys. I'll upload this and I'll give you guys a chance to download all the questions as well. So if you go on the actual video, there's a download for the worksheets or the questions, so you can print it out and try it as you do the video as well, as you watch the video. But back to the questions. Let's go on to the next one. What exam board is this? This one was AQA. It's AQA. Okay. Next question. We don't have a lot of time. I'm going to ignore this question. I'm going to do this topic in another live. This is energy. Let's try this calculation out because I want to focus on moles right now. So a mixture contains 1 kilogram of aluminium, 3 kilograms of iron oxide. Show that aluminium is the limiting reactant. Okay, so this is another part of this topic. Does anyone know what limiting reactant means? Yeah, limiting reactant is a reactant that completely gets used up. So you're going to have a certain amount of aluminium, you're going to have a certain amount of iron oxide, but if you have more of one than the other, then what's going to happen? Let's say, so it's saying aluminium is the limiting reactant, so that means there's less aluminium than iron oxide. Therefore, all the aluminium is going to get used up because there's going to be so much iron oxide that all the aluminium is going to get used up, and you're going to have some iron oxide left over after this reaction happens. That's what limiting reactant means. So another way of saying that, yep, Oscar, you say iron oxide is in excess. In excess means you have extra of it. You have too much iron oxide that not all of it's going to react. But for aluminium, all of it will react. So now the question is, how do we show aluminium is the limiting reactant? How do we show this less of it? What do we need to do, guys? What do you think? It's a tricky one. Find moles, yes. Finding moles is a good start. So this isn't going through those steps that I talked about. To find the limiting reactant, we need to work out the moles of this. We need to work out the moles of this. So, moles of aluminium. How can we work out the moles of aluminium? You need to find the MR first. Exactly. So find the MR. So we're going to do moles is equal to mass over MR. So that would be 1 kilogram divided by the MR of aluminium is given to us here as 27. 1 divided by 27. Can someone tell me what that is? You can do 1,000 grams as well. You can do 1,000 grams. The thing is, let's do it with 1,000. You don't have to do 1,000 because you're going to do the same thing twice. You're going to do 3 and you're going to do 1. But because it's 1 kilogram, technically you should be doing 1,000 grams over 27, but you'd still get the same answer if you did 1 kilograms for both. But okay, let's do 1,000 divided by 27. So that gives us 37. Yep, 37. 37.03. Okay, so that is the moles of aluminium. Let's do the same for Fe2O3. So this time we have 3 kilograms, so 3,000 grams, divided by the MR of iron oxide. Can someone tell me what the MR of iron oxide would be? So that's going to be Fe. So we got Fe here. 2, Fe2 means you have 2 of these, and you have O3, 3 of these. Fe2, so 2 ions and 3 oxygens. Add them all up. Tell me what you guys get. 116. What is MR? MR, guys, is the molar mass you add up all the numbers, the relative atomic masses of all individual elements in that compound. So what was it? 160 guys. I'll tell you what you need to actually put in your calculator just in case you got it wrong. You want to do 56 plus 56 plus 16 plus 16 plus 16. So if you do 3,000 divided by that, what does that give, guys? Yeah, so 160 is for the bottom part. What if you do 3,000 divided by 160? 18.75. Thank you, guys. 18.75. Okay, so these are the two things we have. This is where it gets confusing to some people. So we've got aluminium, we've got Fe2O3, we have 37.03 grams of aluminium, we have 18.7. Is that what it was exactly? 7.5. I'm going to put 7.5. 18.75 grams of iron oxide. So how does this show that the aluminium, remember, how does it show that aluminium's the limiting reactant? There's one more thing we need to do. It's less. Technically, 37.03 is not less than 18.75. So why? So if we got just these numbers and these were the true numbers, it wouldn't mean aluminium is in excess. There's something else we need to look at. Why is aluminium in excess here? You need to divide it by 2. Exactly. Look at the ratio, guys. What this is a 2. This is a 1. So there's a ratio of 2 to 1. So that means you all in this reaction, you have to have double the amount of aluminium than you do Fe2O3. So the question is, do we have double or do we have less? If it's limiting, we should have less than double of this. So let's times this by 2. What is that times by 2? $18.75 times by 2. 37.5, exactly. So if you had 18.75 grams of Fe2O3, that means you need 37.5 grams of aluminium for a full reaction. You only have 37.03, so it's slightly lower. That means you don't have enough aluminium for this reaction, or for the aluminium to, for this reaction to fully react, basically.